Hello grade 10 students, welcome to another virtual class. I am Miss Madhu Badke. We are studying chapter 6 triangles. In previous video class we learned Pythagoras theorem where we proved this theorem using concept of similarity of triangles. Now let's apply the concept of Pythagoras theorem in problem solving. We have been using Pythagoras theorem right from our lower classes, but now the level of difficulty of questions will be a little higher. So continuing with exercise 6.5, we had solved first question in the previous video class, so let's continue with question number 2. PQR is a triangle right angled at P. So let's draw triangle PQR which is right angled at P. And M is a point on QR such that PM is perpendicular to QR. So what are we given? Angle RPQ is 90 degrees in triangle PQR. And we are given PM is perpendicular to RQ. We have to prove that PM square is equal to QM into MR. We are going to modify this equation and write it as two equal ratios. So this will be PM divided by QM. I'm taking QM to the left side, equal to MR divided by 1 PM from here will come on the right side. So we will get MR divided by PM. Now we have to show that these two ratios are equal. To show ratios equal, we will have to show the triangles that contain these sides are similar. Now how to find out the triangles that are similar? We have to look at the terms in the numerator, PM and MR. PM and MR are sides of triangle PMR, and QM and PM are sides of triangle PMQ. So we have to show these two triangles similar. So start the proof by mentioning the triangles in which you are going to find corresponding angles equal. So in triangle PMR and triangle PMQ. In these two triangles, angle RMP and PMQ are going to be equal. Why? Because each is going to be 90 as PM is perpendicular to RQ. Now we have to find one more pair of corresponding angles equal in these two triangles. So let's consider angle R. We will mark it as angle X. Now look at triangle RPM. In this triangle, one angle is 90 degrees, one angle is X. So what will be the third angle? Using angle sum property, we can find out. Let's mark this third angle of this triangle as 1. So using ASP in triangle PMR, we have angle 1 plus 90 degrees plus X equal to 180 degrees. So from here angle 1 will be equal to 90 minus X. So what can we say about angle 2 in triangle MPQ? Notice that angle P is 90 degrees. So angle 1 plus 2 should be 90 degrees. So let's write down this. So we have angle 1 plus angle 2 equal to 90 degrees as angle RPQ is 90 degrees. But we have just shown that angle 1 is equal to 90 minus x. So substituting angle 1 in the above equation, we can find angle 2. So 90 degrees minus x plus angle 2 will be equal to 90 degrees. Equal quantities will cancel. So angle 2 will be equal to x. So what does this imply? So this implies that angle R is equal to angle MPQ, because we have just shown that angle 2 is equal to x. And we have shown earlier that angle RMP is equal to angle PMQ. Now we have two angles of a triangle equal to the corresponding angles of another triangle. So we can say that triangles are similar, and symbolically triangle RPM is similar to triangle PQM. Notice that the vertex R of this triangle correspond to vertex P. M of one triangle corresponds to M of the other triangle. Therefore, P of the first triangle will correspond to Q of the second triangle. So triangle RPM will be similar to triangle PQM by angle-angle criteria. So now we can write down the ratios. PM upon QM is equal to RM upon PM. On cross multiplying, we get PM square equal to RM into QM. So when we have a figure like this, in which we have a right triangle and perpendicular is drawn from the vertex of right angle to the hypotenuse, then these two triangles are similar and the corresponding angles are going to be as shown in the figure. And we can mark the third pair of corresponding angles in these two triangles, which is going to be angle RPM equal to angle MQP. Question number 4 and question number 5 are converse of each other. So we are going to do them side by side so we can see the difference. Question number 4. ABC is an isosceles triangle right angled at C. So let's draw an isosceles right triangle. An isosceles right triangle will have two sides equal. So let BC be equal to CA. So we are given that BC is equal to CA. What do we have to prove? AB square is equal to 2AC square. This is a very simple question. Since it is a right triangle, we can use Pythagoras theorem, which says that the square of hypotenuse will be equal to the sum of squares of other two sides. And we know that hypotenuse is the side opposite to the 90-degree angle. So AB square will be equal to BC square plus CA square. But we are given that BC is equal to CA. So we are going to replace BC by CA. So we get AB square equal to AC square plus AC square, which is 2AC square. So we have arrived at what we have to show. Now question number 5. Triangle ABC is an isosceles triangle with AC equal to BC. If AB square is equal to 2AC square, prove that ABC is a right triangle. So let's draw a right triangle in which two sides are equal, that is AC is equal to BC. We are given that AB square is equal to 2AC square. Then we have to prove that triangle ABC is a right triangle. For this triangle to be right triangle, we will have to show one of the angles as 90 degrees. Let's start with what we are given. AB square is equal to 2AC square. We can write 2AC square as AC square plus AC square. But we know that AC is equal to CB. This is given. So let's replace one of the AC terms in this equation with CB. So we get AC square plus CB square. Now look at this equation. We have AB square equal to AC square plus CB square. Recall the converse of Pythagoras theorem. According to this theorem, if in a triangle square of one side is equal to the sum of squares of other two sides, then the angle opposite to the first side is going to be 90. So this implies angle opposite to AB is 90 degrees. So angle C is 90 degrees. And if angle C is 90 degrees, this implies triangle ABC is right triangle and AB is hypotenuse. Question number 6. ABC is an equilateral triangle of side 2A. Find each of its altitude. Let's draw an equilateral triangle which has all three sides equal, and each of its sides is 2A. The question is to find each of its altitudes. Each triangle has three altitudes, and since this is a symmetrical figure, as all its three sides are equal, the length of altitudes in this triangle are going to be equal. So all three altitudes are going to be equal. Altitude is a line which is drawn from the vertex joining the opposite side such that it is perpendicular to the opposite side. So AD is the altitude. We have studied in lower class that if we draw an altitude to an equilateral triangle, then it will bisect the opposite side. So in an equilateral triangle, altitude can also be called as a median. So point D is the midpoint such that BD is equal to DC. And you can show this by proving these two triangles congruent. However, it's not required here because this is something that we have to know. So now we have triangle ABD, which is right angled triangle. So we can use Pythagoras theorem in this. So let's just draw the triangle that we need. So this is triangle ADB, in which AB is 2A. BD is going to be A, half of BC, and AD is the height of this triangle or the altitude. So we have to find the length of altitude, which is h. Now we can use Pythagoras theorem for these three sides since they are the sides of right triangle. So in right triangle ABD, hypotenuse square, that is AB square, should be equal to the sum of squares of other two sides. So AB square is equal to BD square plus AD square. Let's substitute AB as 2A. So we get 2A square equal to, substitute BD as A. So we get A square plus AD is h, so we get h square. Now since we have to find h, I am going to shift the left hand sides and the right hand sides. Now keeping h square on the left side and shifting a square to the right side so that we can add like terms, we get 3a square. Now taking square root, h is equal to square root of 3a square, which is equal to root 3 times a. So the length of altitude is root 3 times a. Now since we are studying Pythagoras theorem, I have applied Pythagoras theorem to find the altitude. But if in case it is not mentioned in the question that you have to make use of Pythagoras theorem, you can use any other method. Like, we know that area of equilateral triangle is root 3 upon 4 side square. And the formula for area of triangle is half base into height. So if we use this method, area is equal to root 3 upon 4 side square, and that will be equal to half base into height. So side of the equilateral triangle is 2a, so you will substitute s as 2a. Base is also 2a. H is what we have to find. So when we substitute in this, you will get root 3 upon a as the altitude. With this, we come to the end of this video lesson. Your assignment is question number 3, which is a similar question to question number 2. And part of it we have already done in proving Pythagoras theorem. These equations are to be obtained by proving triangles similar. So in this figure, we have 3 triangles, 2 small and 1 big. So you will have 3 sets of triangles that you can show similar, and then you can get each of these results. I have shown how to change this equation into 2 equal ratios. And after that, you can identify the triangles that you have to show similar for each of these questions. See you in the next class. Until then, goodbye.